Classifying polygons. Alright, first off, a polygon, what is that? Well, I see a prefix there, I know. Poly means many. So many sides is what we're talking about. Alright, well maybe that's a little vague. What does many mean? Well, in this case, it means at least 3. So a polygon has many sides, which means it's a closed two-dimensional figure, or 2D figure, with at least 3 sides. Why is it at least 3? Because a triangle is the least number of sides you can have for a polygon. Otherwise it would just be a straight line. Alright, speaking of triangles, all triangles have a certain number of degrees for the sum, which means add, of their interior angles. Do you know what that number is? It's 180. Well, that's pretty cool. Every triangle has 180 degrees inside. Alright, we're going to use that later on. Now there are 2 ways we can classify triangles. One is by their angles and the other one is by their sides. So since we were just talking about angles, let's start with that. Alright, so classifying triangles by their angles and by their sides. Alright, so first, an obtuse triangle. It only takes one obtuse angle. And we can call it an obtuse triangle. And think about why that is. Obtuse means it's greater than 90 but less than 180. So if you had 2 numbers greater than 90, well geez, 100 plus 100 would be 200. That would be too many degrees for a triangle. And I'm just going to draw a little example of an obtuse triangle. So let's just draw an obtuse angle and then just connect them, the endpoints. And that would be an example of an obtuse triangle. Alright, next up, let's talk about a right triangle. And just like obtuse, it only takes one obtuse angle to be an obtuse triangle. It only takes one right 90-degree angle. And drawing an example of that, we're just going to draw 2 perpendicular line segments and then connect them. And I'm going to denote that that's a right angle by putting a box. That's just our math code for 90 degrees. So one right 90-degree angle is a right triangle. You just think you can't have 2 right angles because 90 plus 90 is 180. Then you wouldn't have any degree measurement for the third side, or third angle rather. Alright, and then our last one is acute angle, acute triangle that is. And the acute triangle is so cute that all 3 angles are going to be cute. How cute is that? Alright, Mr. Simon. So they are all acute angles, and I'm going to start by just drawing an acute angle here at the bottom, and then just connecting it to the top. So notice, every angle here is less than 90. Alright, well those are the 3 ways we can classify triangles by their angles, but we haven't begun to talk about by their sides, which is the other way. Well, we have a scalene triangle when no sides are congruent. So no congruent sides. And now just try to draw a scalene triangle. I just drew a short side here, went long, and then longer. So I have 3 different side measurements for my triangle. Alright, and we call it isosceles. So an isosceles triangle is when at least 2 sides are congruent, and think you have 2 sides. Just kidding, you have 2 eyes. So two eyes, think of the IS for the isosceles. You have at least two eyes. Some of you might have three. I know all teachers have an eye in the back of their head. So, we're watching you. I'm going to draw an example just going diagonally up, then diagonally down. And these two, I'm going to use hash marks to show that their two sides are congruent. And our last one, you may know, is called equilateral. So equilateral triangle is when we have three congruent sides. And this one's easy to remember if you just look at the prefix. Equa meaning equal sides. So all three sides are equal, and we can show that just by drawing an acute triangle with all the sides the same. And again, I'm going to denote that with hash marks. So since they each get one hash mark, that means they're all the same measurement. Alright, so every triangle we can name by both their sides and by their angles. So they get two names, just like you get a first name and a last name. Some of you have middle names. Alright, pause the video if you haven't finished copying that, because we're going to move on to quadrilaterals. And here we are. We're going to make a chart, so make sure you have enough room on your page there. You want to at least be able to take up, I'd say, a quarter to a third of your page. And write quadrilaterals at the top. Underneath quadrilaterals, we're going to write four sides. We're just defining them. And then I have two branches coming off of quadrilaterals as we get more specific. And I have parallelogram and trapezoid written underneath. So parallelogram has two pair of parallel, that's our symbol, just like a slanted 11. So parallel sides. And trapezoid has exactly one pair of parallel sides. Alright, so branching off from parallelogram, we're done with trapezoid. But branching off from parallelogram now, we have a rectangle and a rhombus. So a rectangle has four right 90-degree angles, and a rhombus has four congruent sides. Now, what do you think we call it when a rectangle and a rhombus, if they're both a rectangle and a rhombus? That's right, they'd be a square. So that's going to be our last classification. So a square has four right angles and four congruent sides. So some rectangles are squares and some rhombuses are squares, but all squares are rectangles and all squares are rhombuses. So as we read upward here, we can use the word all. As we read downward, we can use the word some. This is very important when we start differentiating these. So, for instance, all trapezoids are quadrilaterals. They all have four sides. I'm going to read upwards again. All parallelograms are quadrilaterals. They have four sides. All rectangles are parallelograms. They have two pair of parallel sides. All rhombuses have two pair of parallel sides. All squares are rectangles. All squares are rhombuses. But now as I start reading downward, then it's going to be using the word some. So some quadrilaterals are parallelograms. Some quadrilaterals are trapezoids. Some parallelograms are rhombuses. Some parallelograms are rectangles. Some rectangles are squares, and some rhombuses are squares if they have four right angles. Right? Some rectangles are squares if they have four congruent sides. Alright, let's define the word regular polygon. That's when all angles and all sides are congruent. So look at all these figures. We have all of these triangles. We have a triangle here. We have a pentagon, 6 sides hexagon, and then that's a square. These are all regular because all their angles are the same. Look at these 3 angles. Whoops. That angle, and this angle, they're all the same. This angle is the same as this angle. And then we can also talk about their sides. That side's the same as this side. We use hash marks with that. All these sides are the same. And that's how it works. So we have specific names for 3-sided figures, triangles. What are they? Equilateral. And then we have a name for a 4-sided, if it's regular. What's that called? A square. And after that, we just say it's a regular pentagon or a regular hexagon and so forth. So let's copy down our examples I just went over. We could have an equilateral triangle like this. If we had 4 sides, it'd be called a square, like that green quadrilateral. And then after that, we just use the word regular. So regular pentagon is for a 5-sided figure. Regular hexagons for a 6-sided figure. And then it just uses the word regular from there. So regular heptagon, octagon, nonagon, decagon, 11gon, dodecagon, etc. Alright, the last thing we're going over is how do we find the perimeter for a regular polygon? There's got to be an easy way, right? Well, geez, you know all the sides are the same, so if you find one side, perimeter means just add them all up, then you can multiply that by the number of sides. So really it's just going to be capital P for perimeter equals the number of sides times the side length. Alright. So, for instance, if we had an octagon, how many sides does an octagon have? Well, an octagon has 8 sides, so our perimeter would just be 8 times whatever our side length is. We could say x. So if your side length was 5, 8 times 5, you would have a perimeter of 40. If your side length was 10, 8 times 10, your perimeter would be 80. And it's really that simple. But that only works if they are regular. And that's going to wrap it up. Thanks for watching.